Hi, this is Mr. Moreno, and this is for PASS 6, Mechanical and Chemical Weathering is the name of the chapter, 4.1. Now today I will attempt something I've never done before. I will try to do this whole video without looking down at the book or looking at the computer, which are this way and that way. I'm trying to look just at the camera, at you. Anyways, the reason is that this I think is, well, at least to me it's pretty easy because I've done it many, many times. So this one's about weathering. And what is weathering? Well, you guys know the name weather, right? The word weather. So weathering is, I wrote it here, when the weather breaks down rocks. And by the weather, in this case, we mean usually just air or oxygen in the air. The oxygen in the air. And the water. So, but it could be the air, the wind as well. So weathering, there are two types of weathering. There's mechanical weathering and chemical weathering. Let's talk about mechanical weathering first. Now, mechanical weathering, there can be 4 different kinds of mechanical weathering. Ice wedging. Ice wedging is when water goes into the cracks of rocks, but then it gets cold because the temperature drops, and as you may have learned in other science classes, ice expands when it freezes. That's why if you put a soda can in the freezer, it'll expand and it'll break. You shouldn't do that. So the same thing happens with the little itty bits of water in the rock. When the water expands as it freezes, it breaks the rock in half. Now, of course, this might not happen like right away or the first season, but think about this happening over many years, then hundreds of years, thousands of years. Eventually, this can crack a rock, a big rock, in half because it keeps expanding as it freezes. The next one is pressure release. This one's a little bit harder to understand. So imagine I have a ball, a rubber ball. I can squeeze it a lot, right? Or I can do this with rice too. Imagine I have rice and just squeeze the rice into a very, very tight ball, right? There's a lot of pressure because I'm squeezing. But then when I let go of it, there's no more pressure. Inside, it's still pretty packed together. But think about the outside of the rice ball. Here I draw a little rice ball. The outside of the rice ball starts breaking up a little bit. It starts expanding a little bit because the pressure is off. That is pressure release. We are releasing the pressure, and it's especially evident on the outside, the very last layer. So sometimes they call it the onion effect because it's like the outer layers of an onion. Next one is plant growth, and if you remind me in class, I have a lot of pictures of this happening in the temples of Angkor Wat in Cambodia. But plant growth is when a tree or any kind of plant that has strong roots starts growing. And these roots might not seem strong by themselves, but if you give them enough time to start growing, they can break through cement, through concrete, through almost anything. And this is a big deal, especially near monuments. Like if you've ever been to Gyeongbokgung, they will try to cut any sort of roots that are growing into buildings because they can really break the building. Now, in the temples in Cambodia, if you look it up on your computer, the temple, not Angkor Wat, Ta Prohm, the plants are growing through the buildings, and they are actually, in some cases, they're expanding out. Now, that one they haven't cut down because it looks kind of cool, so they just let it grow, but maybe if it grows too far, they'll start cutting it. But I've seen in many other places where they have monuments, they'll start cutting the roots because they can break it in half. And the last one, and the most difficult to understand, is abrasion. Now, abrasion is, in simple words, rubbing. Now, think about 2 erasers. If I go like this to 2 erasers, maybe you'll see itty bits of eraser fall down, right? But imagine if I have 2 erasers and I rub like this for hundreds of years. As you can imagine, eventually the eraser just falls apart. It breaks apart because there's too much rubbing going on. The very outer surface keeps wearing down little by little. and eventually it will just all crumble. Now, I looked down once, so that's -1 for me. Chemical weathering. Chemical weathering means not something, well, I guess I should explain mechanical first. Mechanical is something you do with force, with pushing and pulling and breaking and rubbing together. Physical force. But chemical is that it means that something is happening in a very microscopic, I guess you can call it microscopic. Anyways, in a very small scale. So for you to understand this, and if you didn't see the chapter 2 introduction video, you should go watch that again. But you need to understand what atoms are. Atoms are the tiniest bits of matter that link together. Now here I drew an atom, or I wrote an atom, NaCl. Na is sodium, Cl is chlorine, chloride. And together, it's salt. But what happens when you put salt into water? Water tends to dissolve many things. That is a chemical reaction. And NaCl splits into Na plus 1 and Cl minus 1. You don't need to know what this plus 1 and minus 1 means, but you should know that inside the water, when you break it up, there are actually the individual pieces of this salt. And water tends to do this to a lot of things, not just salt. If you've ever mixed anything in water, you've seen that this can happen to many compounds. Another chemical reaction happens with oxygen. Oxygen tends to react with a lot of things, especially metals. Now, that is helpful sometimes when we want to know how old something is. You can test the oxygen or oxidation. Let me write that word down. Oxidize. I don't know how to spell it. Maybe that's how you spell it. But anyways, the oxidation, that means that oxygen has reacted with a metal to create something we call rust. Now, I draw a little picture of a bicycle here because this is how I discovered rust. If you leave your bicycle out in the rain and it gets wet and there's all this weathering that happens, eventually the oxygen gets into that metal. And if you leave it out for years, or maybe a couple of years, not many years, you will see something orange starts forming on the metal. That is rust. And rust is oxidized metal or something that's oxidized. So it starts turning orange, and that is not good, right? It's pretty much ruined. Now, we have special ways to prevent rust, but we're not going to cover that here. You just should know that oxidation is something that naturally happens in nature. Okay, bye. Okay, really, bye.